Potential causes of buzzing can include a ground loop between the audio system and the electrical system, improper grounding of audio equipment, faulty cables or connections, and interference from other electrical devices. Polarity reversal, specifically creating a positive ground, should not affect the audio equipment's operation or cause buzzing. Adequate grounding is essential to prevent ground loops and buzzing. Here are some troubleshooting steps. Firstly, check electrical connections to ensure they are tight and secure. Secondly, verify that all audio equipment is properly grounded. Thirdly, inspect cables for damage or loose connections. Fourthly, test for ground loops by isolating the audio system from the electrical system. For example, unplug the power cord from the soundboard. If the buzzing persists after taking those steps, it is not likely an electrical wiring issue. Consult with a qualified audio technician to identify and resolve the buzzing. The electrician is responsible for ensuring proper electrical wiring, including adequate grounding. The sound team is responsible for proper grounding of their equipment, cable management, and troubleshooting audio issues. It is recommended to communicate with the sound team to determine the specific nature of the buzzing and the troubleshooting steps they have taken. Offer assistance in checking electrical connections and ensuring proper grounding for the receptacles installed for their equipment. Recommend that the sound team consult with an audio technician to resolve the buzzing issue. When troubleshooting electrical noise in audio systems, a systematic approach is crucial. Understanding the potential sources of the noise and employing effective diagnostic techniques will lead to a faster resolution. Ground loops are a very common cause of buzzing. They occur when there are multiple paths to ground, creating a loop that can act as an antenna, picking up stray electromagnetic fields. This induces a current in the loop, which manifests as audible noise. Ensuring a single point of ground for all equipment can often eliminate ground loops. The first step is to visually inspect all electrical connections related to the audio equipment. Check for loose connections, corroded terminals, or damaged wiring. Even a slightly loose connection can introduce noise into the system. Tighten all screws and terminals, and replace any damaged wiring. Ensure that all equipment is properly grounded. This means that the ground connection on each piece of equipment is connected to a common ground point. Verify that the ground connection is secure and free of corrosion. If using extension cords or power strips, make sure they are grounded and of sufficient gauge to handle the current requirements of the equipment. Audio cables, especially unbalanced cables, can be susceptible to noise. Inspect the cables for damage, such as cuts or fraying. Ensure that the connectors are securely attached and free of corrosion. Try replacing cables with known good cables to see if the noise disappears. Balanced cables are less susceptible to noise than unbalanced cables because they use differential signaling, which cancels out common mode noise. If possible, switch to balanced cables for all audio connections. Interference from other electrical devices can also cause buzzing. Common sources of interference include lighting dimmers, fluorescent lights, and switching power supplies. Try turning off these devices one at a time to see if the noise disappears. If a particular device is identified as the source of the noise, try moving it further away from the audio equipment or using shielded cables. Electrical polarity issues should not directly cause buzzing. However, incorrect polarity can create other problems, such as increased susceptibility to noise and potential safety hazards. Use a multimeter to verify that the polarity of all electrical outlets is correct. If incorrect polarity is found, correct it immediately. A dedicated circuit for the audio equipment can help to isolate it from other electrical devices and reduce noise. A dedicated circuit should be run directly from the electrical panel to the audio equipment, and it should not share any other loads. An isolation transformer can be used to isolate the audio equipment from the electrical system. This can help to eliminate ground loops and reduce noise. Connect the isolation transformer between the electrical outlet and the audio equipment. A power conditioner can filter out noise and voltage fluctuations from the electrical supply. This can improve the performance and reliability of the audio equipment. Plug the audio equipment into the power conditioner. If the buzzing persists after trying all of these steps, It is likely a more complex issue that requires the expertise of a qualified audio technician. An audio technician has the tools and knowledge to diagnose and resolve a wide range of audio problems. When communicating with the sound team, ask them to describe the noise in detail. Is it a constant hum, a buzz, or a crackle? When does the noise occur? Does it happen all the time, or only when certain equipment is turned on? What troubleshooting steps have they already taken? Providing them with assistance in checking electrical connections and ensuring proper grounding demonstrates a commitment to resolving the issue. Offer to verify that the receptacles installed for their equipment are properly grounded and that the polarity is correct. Recommend that the sound team consult with an audio technician if the buzzing persists. An audio technician can perform more advanced troubleshooting techniques, such as using an oscilloscope to analyze the noise signal and identify its source. By following these steps, the source of the buzzing can be identified and resolved, resulting in a clean and noise-free audio system. Additionally, let's explore some further aspects to consider when dealing with electrical noise issues in audio systems, including advanced troubleshooting techniques, best practices for grounding, and preventative measures to minimize future problems. Advanced troubleshooting techniques may involve using specialized equipment and a deeper understanding of electrical and audio principles. A spectrum analyzer can display the frequency content of the noise, helping to identify its source. For example, a 60 Hz hum is often caused by ground loop, while higher frequency noise may be caused by switching power supplies or other electronic devices. An oscilloscope can display the waveform of the noise, providing more detailed information about its characteristics. This can help to differentiate between different types of noise and identify the underlying cause. A signal tracer can be used to trace the noise signal through the audio system, helping to pinpoint the exact location where the noise is being introduced. This involves injecting a test signal into the system and then using a probe to follow the signal path until the noise is detected. Best practices for grounding are important for preventing ground loops and minimizing noise. Star grounding involves connecting all ground wires to a single point, typically at the electrical panel. This minimizes the potential for ground loops by ensuring that there is only one path to ground. Ground lift adapters can be used to break the ground connection between two pieces of equipment. However, ground lift adapters should be used with caution, as they can create a safety hazard. Shielded cables are important for reducing noise pickup, especially in environments with high levels of electromagnetic interference. Shielded cables have a conductive layer that surrounds the signal conductors, which helps to block out external noise. Preventative measures can be taken to minimize future problems. Proper cable management helps to prevent cable damage and reduces the risk of noise pickup. Cables should be neatly organized and secured, and they should be kept away from sources of heat and moisture. Regular maintenance of electrical and audio equipment can help to identify and correct potential problems before they cause noise. This includes checking connections, cleaning contacts, and inspecting cables for damage. Surge protection protects equipment from voltage spikes and surges, which can damage components and introduce noise into the system. Surge protectors should be installed on all electrical circuits that supply power to audio equipment. Electrical codes and regulations provide guidelines for safe and proper electrical wiring practices. Adhering to these codes and regulations helps to ensure that the electrical system is safe and reliable. Additionally, consider these aspects related to the situation. Firstly, understanding common mode noise. Common mode noise is a type of noise that is present on both conductors of a balanced audio signal. It is typically caused by electromagnetic interference from external sources, such as power lines or radio transmitters. Balanced audio circuits are designed to reject common mode noise, but if the noise is too strong, it can still be audible. Secondly, differential mode noise is a type of noise that is present on only one conductor of an audio signal. It is typically caused by faulty components or wiring within the audio equipment. Balanced audio circuits are not effective at rejecting differential mode noise, so it is important to identify and correct the source of the noise. Thirdly, electromagnetic compatibility, or IMC, refers to the ability of equipment to function properly in its intended electromagnetic environment without causing interference to other equipment. E&C testing is often required for electronic devices to ensure that they meet certain standards for emissions and immunity. Fourthly, electrostatic discharge, or ES, is the sudden flow of electricity between two objects with different electrical potentials. ESD can damage sensitive electronic components, so it is important to take precautions to prevent it. This includes using ESD mats and wrist straps when working with electronic equipment. Fifthly, harmonic distortion is a type of distortion that occurs when a signal is amplified or processed in a nonlinear way. It can cause the signal to sound harsh or unnatural. Minimizing harmonic distortion is important for achieving high-quality audio. Sixthly, intermodulation distortion is a type of distortion that occurs when two or more signals are mixed together in a nonlinear way. It can cause the signal to sound muddy or unclear. Minimizing intermodulation distortion is also important for achieving high-quality audio. Seventhly, noise floor is the level of background noise in an audio system. A low noise floor is desirable for achieving high-quality audio. There are several factors that can contribute to the noise floor, including thermal noise, shot noise, and flicker noise. Eighthly, signal-to-noise ratio, or SNR, is the ratio of the desired signal level to the noise floor. A high SNR is desirable for achieving high-quality audio. Improving the SNR can be achieved by increasing the signal level or by reducing the noise floor. Ninthly, transient response refers to the ability of an audio system to accurately reproduce sudden changes in the audio signal. A good transient response is important for achieving a natural and realistic sound. Tenthly, frequency response refers to the range of frequencies that an audio system can accurately reproduce. A wide and flat frequency response is desirable for achieving high-quality audio. It is also important to consider the specific grounding requirements of different types of audio equipment. Some equipment may require a dedicated ground connection, while other equipment may be more sensitive to ground loops. Understanding the grounding requirements of each piece of equipment is essential for achieving a noise-free audio system. When troubleshooting noise problems, it is often helpful to isolate the problem to a specific piece of equipment or a specific section of the audio system. This can be done by disconnecting or bypassing different parts of the system until the noise disappears. Once the problem has been isolated, it is easier to identify the underlying cause and implement a solution. In conclusion, troubleshooting electrical noise in audio systems requires a systematic approach and a thorough understanding of electrical and audio principles. By following the steps outlined above and considering the additional aspects discussed, you can effectively diagnose and resolve noise problems and achieve a clean and noise-free audio system. Also be aware of the electrical codes in the location, such as the National Electric Code, which specifies that if there is a metal water pipe that is within 5 feet of the location, then it needs to be connected to a grounding electrode. Another aspect is that if the equipment grounding conductor is smaller than the sizes in NEC Table 250.122, it needs to be upsized. NEC Section 250.122b specifies that when ungrounded conductors are increased in size, equipment grounding conductors shall be increased in size proportionately according to the circular mil area of the ungrounded conductors. These are very important code rules to remember when dealing with grounding and electrical systems. You may want to consult with a qualified electrician.